In every regard, this project was inspired by nature. As an engineer, I'm interested in how things work. As an engineer for ESB, I'm interested in how things can work with less carbon. And the East Anglia greenhouses are a terrific example of how we can use what already is in our environment to make things work with a lot less greenhouse gas emissions.
The global population is set to reach 10.5 billion by 2050. Feeding everyone means substantially increasing local food production and finding solutions that don't rely on fossil fuels. These two greenhouses represent part of that solution. They cover 29 hectares of year-round growing space and use 75% less carbon than traditional greenhouses. And they have the capacity to produce 12% of the tomatoes grown in the UK or 13% of the cucumbers consumed in the UK. It looks rather pastoral, but there's actually a ton of technology required to deliver that capacity. Luckily, we have a fantastic partner in ESB.
Our partnership with low carbon farming marks a few world firsts. Firstly, these are the largest greenhouses in the UK, covering an area larger than 7 Twickenham stadiums. Secondly, between the two sites, we are producing more than 72 megawatts of renewable heat from a previously untapped resource, providing 90% of the greenhouse's requirements, making this the most efficient system of its kind in the UK.
The renewable heating system is comprised of open and closed circulation pump network loops, which transport waste heat from nearby waste treatment facilities to the greenhouses. The original design relied solely on the heat pumps, but we realised additional CO2 was needed to feed the plants, so we added gas-fired combined heating and power units to provide electricity for the heat pumps, while providing the plants with the necessary carbon dioxide. It all makes for a rather elegant solution.
Using waste heat from the earth, air and water is not new, but using clean water discharge from a water recycling plant, well, that marks a significant development in our ability to meet our carbon targets and supply clean energy for large energy users, potentially cities as a whole. This system generates enough thermal power to heat about 20,000 new homes. It produces more than 90% of the glasshouse's heat requirements, and it emits a quarter of the CO2 of other greenhouses, equivalent to eliminating 1.2 million tonnes of carbon from the atmosphere. Not a bad result from observing some ducks enjoying a bath from a water recycling runoff on a cold winter's day.